Hello, everybody. It's April 5th. Today we have a special edition of the Antelope Roundtable. We've got some friends joining the call from the ENF to give us a demo of Leap 4.0. So I'll hand it over to Brian to introduce that.
Yeah, I'm super excited to have some of the Leap core developers here today to go over what we've been working on for 4.0. Just as a sort of refresher that everyone on this call and watching this video probably already knows, EOS has always sort of, excelled at performance, scalability, and reliability, and those things have been kind of reinforced with what we've been working on with 4.0. I just, on a personal note, this is my first major release that I've been involved with the whole way. I'd like to thank everyone for the warm welcome to the community and, pulling me in. I'm really proud of what the team has put together here for 4.0. There have been some lessons learned on my part, so I'm eager in the next release to have more direct community involvement, earlier feedback on the problems and opportunities we're prioritizing, and of course, the proposed approach to the solutions that we're developing. And of course, part of that too is demos like this one. So I'm really excited to be doing that today. Some of the themes for the release, just to kind of set the context before I hand it off to our first demo participants, are that in 4.0, we built features to provide even higher performance than, EOS is known for, with some multi-threading features as a common thread. We also built features to reduce latency and enable faster block propagation, and features to provide more control for node operators around data control and visibility. And then, lastly, just kind of an odd assortment of quality of life improvements, if you will, for node operators. So those are the big sort of buckets of themes. As we're watching through the demos, see if you could guess which ones were targeted at what things. But with that, I will hand it over for our first sort of demo presenter, which is Lynn and Kevin. I don't know which one of you is going to sort of run, but have at it.
Yeah, I'll do the first part, and Kevin will do the second part.
Right.
So can I share my screen?
Yeah, Daniel might have to give you permission.
You are good to go now.
Oh. Okay, let's try again. Okay, yeah. You got my screen. Can you guys? Oh, sorry. So you guys can see my screen. Yep. So let me go through there. Okay, this way I don't have to memorize. Okay. So in 4.0, so we implement a new RTC endpoint for sending read-only transaction, and then we went on to parallelize it, and then we went on to parallelize all the read-only tasks. So that's our thing. That's our three features. And so first, so I'm going to talk about how a read-only transaction look like. So our read-only transaction, so basically it's similar to regular transaction, but it has some difference. First, so the actions when you in a transaction cannot modify states. And we have asserts in place to prevent accidental state changes. Also, we don't allow any authorization or signature in the read-only transactions. This way, so the transaction will not be sent out to the other node. And also, we make sure there's no side effect after a read-only transaction is run and is executed. It will not be put into the block. And because for its read-only transaction, so we make sure the action trace always return, and also because it's read-only transaction, so we don't do deep mine logging, and for read also in this release, we put for read-only transaction, also for compute transaction, we define them as a transient transaction. For these two types of transactions, we provide a separate transaction timing summary. Also, we provide a separate producer trace login. So now let me show you how this look like. So I already have a contract. So here is just a regular contract. So yeah, this is just for so this one is a person. So all the similar. So the person is defined as has ID, has key, age. So basically as so you can insert, update, and get the data from this table. So this is the contract. So let me show you. So now I already have before the demo, I already have a notice start. It's here. Also, I already set up a contract and create an account, and I already have built a read-only transaction. So now let me show you how it looks like. So here, this is okay. So you can see this in this transaction. So we don't have authorization, and so this is just the action is get age, and also so all other empty the fields are empty. So now if I'm going to try to now I'm going to use clears to send the read-only transaction. In the clears, so we already updated clears. We added one new option in the send option, or in the push transaction and in the push action. We have that. So here, so if you just now, if I don't, if in the old way, if I don't say it, so now if I do this, so actually it's yeah, because so this will fail because I don't have any authorization. But here, if I say I put the read here, if you use the read option, so this is for send the read-only transaction. Here you can see. So now, yes. So now you can see the return, but because I don't have any record for this, so then you will say you can see the record does not exist. But if now I insert a record there, oh, show you what? Oh, sorry. Yeah, it's sorry. Yeah, I think I could have another bit too. I can do. Okay, like my send is not working anymore. So sorry. So now I needed to. Okay. Let me see why is this one? Just too quick. Yeah, I can do a quick one. So I hope. Sorry, yeah, let me just restart my. Yeah, because I started it at 40. Sorry about it. Yeah, so now this just reset the coding. So yeah, but yeah, so by that should I need to just
perhaps while you're doing a moment of debug.
Sorry, yes. Yeah, but I can talk about the parameterization.
Sure.
Yeah, sorry. Yeah. So I'll come back to. So after we finish the read-only transaction, so we went on to parallelize the read-only transaction. After that, also Kevin and also noticed that also we can even parallelize more. So now we parallelize read-only transaction. Also we parallelize all the read-only tasks. I mean anything which can be run in parallel, we parallelize. So that's here. So we divide all the transaction tasks into like two categories. So here So we identify the read-only transaction and the tasks which can run in parallel among them. So like get info, get block all, most of majority of the only get which can run in parallel. So we make sure they can run in parallel. And the idea is we divide the execution into two windows, read window and the write window. The write window, so it's similar to the regular window. So both the read-only transaction and the read-write transaction can run, but they run sequentially and they run on one thread. But then in the read window, we only allow read-only transaction and the read-only task run, but they are run in parallel and they run in multi-thread. So basically, so now for this we have so the operator needed to configure 3 parameters. So you needed to configure how many threads you want to run. So if the threads, number of threads is 0, then the feature is not enabled. Also, you need to specify how long for the write window and for the read window last. So yeah, you need to provide these 3 parameters. And so yeah, also for the personalization, so for now we only allow it to run on API node, because so we don't want to interruption with the production. So Kevin, so can you see more? So then I repair my my nodes.
Yeah, it looked like your wallet got locked on you there. So you need to unlock your wallet. Yeah, so a little bit more there on what Lynn was talking about, the read-only windows and the write windows. So you can configure those. The defaults are just kind of numbers we picked out. I think you'll probably be interested in tweaking those. So if you're an API provider, for example, you might want to set the read-only write window time to be rather large. Like you could set it to be maybe 400 milliseconds, and you can set the write window to be tiny. Really, you can make it just 1 for that matter, because the block, when a block is received, it will be applied, which implies that it will switch automatically to the write window for you. So if all you're interested in doing is providing GET calls to users, you can set a very large read window and a very small write window. Now, of course, your write window will be used for things like push transaction and, well, yeah, basically that, and compute transaction, push transaction, compute transaction. So, if you got a node that's doing both, serving push transactions and GET calls, like get table rows, then, you'll do those separately. Now, if you proxy those to 2 different nodes, then you could set up one node that's in the write window always. So you disable the read-only capability on that node, and it can serve push transaction. And then you could proxy all the GET calls to a node that's configured for a very large read window. So, that might be one way that you might want to do that. And then you can crank up the number of threads on the node that's started on those reads, and it will provide get table row calls multi-threaded then, which is pretty cool actually. So that's
yes. Yeah, thanks, Kevin. In our testing, we noticed the performance gain is quite big. So before, in one of our tests, we have a large number of transactions and all the read-only tasks. So before that, my test was on more than around 400, maybe 450 seconds. So now with this, it's around 300 seconds. So it's big again for all the GET actions. I mean, not only read-only transaction, but also the other ones. Yeah, so now, I already set up. So now let me show. So now if I say, can you push transaction, get this is my transaction. Then if I say read, so it will just read. So now you say, I put the age to 15. I have one of my insert. So this one. So this is insert record. So also, and also you can just use push action. Also you can do that. So So okay, yeah. So that's all for my demo, and thanks Kevin for the explanation. Yeah, and we feel so this feature it may improve the performance of at least for all the read actions quite a bit.
Right. Okay. Thank you. If anybody has questions, please take a note of them. I want to make sure we get through all the demos, so take a note of them. If we have time for Q&A at the end, we'll do that. And if we run out of time, you can send them to me on Telegram. It's just at bhazard on Telegram. So next up, we have Vlad.
Yes, I'm ready to share the screen. I think it should work. Let me see. Yeah, please let me know if you can see my screen.
Yep, looks good.
Okay, so yeah, I kind of initially planned for 5 minutes. I'll try to stick to stick with the schedule. So I'll cover it. This is probably, hopefully, in that amount. I wanted to show you one of the additions that we made for 4.0, which is requested from some time feature about ability to schedule snapshots for a future time, and also ability to schedule recurring snapshots that would be taken through certain intervals automatically, and ability to manage several of these schedules, cancel them, view them. And we pretty much introduced 3 additional API calls which allow you to do all of this. This is the first revision. It does not, for example, have pagination for a snapshot request. So if you have a lot of them, but we're not anticipating that there will be too many of them. And also, one of the things which is really important here is that this snapshot schedule is being stored on a disk as a JSON file. I will show you right now. And you can edit it manually. You can see what is scheduled there. And of course, it survives restarts. So it's your schedule is not lost when node is being restarted for some reason. I actually created, to simplify things and make it smoothly yesterday, just a simple repo. I kind of share the link to that, which contains just a very simple examples of this API usage. And I'm just going to briefly show things here. So for example, the scripts are all numbered from 0 to 4, I think 5. And it has kind of cleanup. Then it runs Nodios with a basic options here. Then we will do one-time snapshot, and let me kind of make it a little bigger. So this is one of the API endpoints that I showed you before, so which is called right now we had create snapshot here and we haven't deprecated it yet. It's still working, but this new actually endpoint called schedule snapshot, and you can post for example in a body JSON with parameters like start block number, end block number, and also I would say block spacing, which is for recurring snapshots. Here, for example, this one, it really you're asking system to create snapshot at the specific height in the future. It will be created, and this schedule will be automatically updated and won't be active anymore because it's already executed. It's a one-time thing. For recurring snapshot, for simplicity, I put here that you can specify also block start, block end at which the schedule will start and end. And the spacing between the snapshot, here I specified only spacing. That means that it will execute as soon as possible and will be repeating every spacing blocks. So yeah, enough for that talk. Let's kind of show something. So I have this script, so let's do cleanup, and let's start Node.js, and we can see the Node.js is running here, and blocks are being generated, and let's try. First thing, we will go to the local folder and see that there is no snapshots available here. There is no schedule. Nothing here available. Let's try to schedule a one-time snapshot, and let's see which height we want to make it happen. Let's do 100. Okay, so you're getting as a result the confirmation that snapshot is being scheduled. Yeah, it's already 100, so so it already happened, and we can see that the schedule already cleaned. Let's just I wanted to show that. Let's schedule it for just a little bit more, like 180. Okay, so if we can go here, we can see that there is one item in the schedule that is waiting for a block number 180. And at this point, there will be a second snapshot. Oh, you can see it here. It's already taken. So here we go. That's how the one-time snapshot for the future date is working. The most interesting feature is recurring snapshots, and let's do that. So one second, just first of all, if we I have a really kind of simple script here that takes the snapshots in the folder and converts them to JSON using libutil. I'll just show it in a few minutes. Let's run it quickly and just to see what block numbers are being associated with a snapshot. And you can see that this is exactly 100, and this one is 180. So they've been generated properly. And let's try to do a recurring snapshot, which is most interesting. So spacing, 20 blocks. And if we go to this folder, we can see that we have this only one snapshot request, and it starts immediately. And that was the block number at which we posted this request, and the spacing is 2, and the snapshot request ID is 2. So, and you can see that this folder is being populated with the snapshots, which are happening every 20 blocks. And that's basically, since I haven't specified the end, this will kind of, I would say, process until you terminate it, right? And for that, there is a request that I mentioned before, which we called unscheduled snapshot, which is a very kind of simple script here that is calling unscheduled snapshot with just a single parameter, which is ID of the snapshot that you want to unschedule. Let's unschedule it right now. And it's 4, right? And it shows which snapshots are already scheduled, and we want to unschedule number 2. Done. So if we will go to this folder, right, so there is no more snapshots are being generated, and it's all done. we don't have anything in the schedule, nothing. And at the end, let's kind of convert all the snapshots to the JSONs, and we'll see that 504, this one is 484, so they are 20 blocks apart, all of them. That's pretty much it for scheduling snapshots functionality. It only has 3 requests. Just one correction, just keep in mind, there is a document here posted, which I think in one place needs update because it's the names kind of that this request are expecting. It's a start block num, end block num, and actually a block spacing, and these are just kind of 3 parameters for the scheduling. And that's please.
Yeah, sorry to cut in. So we're to keep on pace, move to the Leap util enhancements and probably keep that one brief if we can.
Yeah, I can do it really quickly. So that's for Snapshot, and also we as you know, we have a new tool which is called Leap util, and basically I just kind of in 1 minute I can show a few things here. So Leap util is getting more and more functionality built in, and you can please go ahead and explore it if you haven't done so. And we have kind of a variety of options here which are exposed with a help all command. Actually, also we updated Kleos to support help in much more convenient form here. So it's really kind of, I would say, you can understand what your kind of what are tree of sub commands are happening. And also, if you've done installation and everything properly, there is autocomplete working, and you can do things like, for example, that, which I'm pressing the tab button and it's doing stuff. We also have incoming feature which will be kind of reporting for clean on, clean shutdown, which is right now in pull request, which is getting into Leap util. And yeah, I think I'm done. So that's pretty much it.
Awesome, thanks, Vlad. So again, if anyone has any questions, please take note of them, and we'll circle back to them if we have extra time at the end, or you could send them to me on Telegram at bhazard, and I'll make sure to funnel them through and get you to the right people for answers. All right, with that, we'll go to, I believe, Peter next. Let me make sure. Yes, Peter next.
All right, can you see my screen? I think so. Awesome. So I'm here to talk a little bit today about a piece of work that a utility that we've been working on in the background, and kind of bringing it to the forefront today to give you some idea of what's out there and kind of the utility that it provides. For the past several months, we've been working on a performance harness testbed, and this was originally thought to give us a better way to kind of run some performance metrics against different operational modes of Node.js, especially for developers to see how their performance or their improvements may be affecting performance in the ecosystem. So I'm here. I'm not really going to demo much today because the reality of these tests are that they take quite a bit of time to run, but I have run some of them, and I will walk through what the outputs are so you can see them. But I wanted to initially start with walking you through what's involved in the performance harness, what's there today. So there are kind of 3 different levels that you can interact with the performance harness. And starting at the kind of the basic, the lowest layer is the performance test basic script. And that script is there to create and run a single performance test. What you can do is it targets a configurable TPS setting. So we were looking to measure as an initial performance metric the transaction throughput that we could support in a block producer mode. And so what the simple basic test allows you to do is configure how many transactions per second would you like to target and how long would you like to generate that load for. And then at the end, it does some analysis to determine success factors, and then also some reporting on the analysis to give you some of the performance metrics at the end. And so this is kind of the lowest layer of the performance harness. And I will call out here quickly that if you want some examples of how to run this, there are some examples in the README that's provided at the top level of the performance tests directory. There's a good write-up there on how to use this tool. So if I leave something out today, that's a good reference for you to go back and look at. But there are also, in our CI/CD, there are several of these being run, both some top-level performance test runs, as well as some lower-level performance test basic runs. And you can kind of see how we've set those up. In CI/CD, we've kind of curated them to be a little bit shorter, and just to kind of prove out that we haven't broken the interface and how the test suite runs. But that gives you a good idea of kind of what typical configurations might be interesting to mess around with. But back to this, how does the performance test basic achieve this? And so it has a couple components that we've developed to also help in this manner. So the first one is there's a script called launch transaction generators, and this has been added to the test harness package Python module. And this is really useful. There's been a lot of work going on in our integration testing, our test harness, and it makes it a lot more usable, but we added this in there as well. And what this allows you to do is, given, say, a TPS, a transaction per second load that you'd like to generate, it'll do some calculations for you based on what you think a single transaction generator on your specific system can handle. And it might be up to you to determine that for your own system. But what this will do is, given a large TPS, it'll fan that out across multiple transaction generators to generate that load in your system to actually do some of these performance tests. And that brings up the transaction generator. This was a new piece that was developed recently as well. And this kind of steps in and replaces the transaction gen plugin that, so I had some questions about how well it was working and how we were using it in the system. And our goal here was to really try to own in and like zero in on being able to test components without, duplicating the environment. So we didn't want to use Node.EOS to test Node.EOS, or by having to load up a plugin in Node.EOS to then test Node.EOS, it was kind of like you were double dipping and not getting kind of a clear-cut performance measurement. So this is a pure C++ implementation of a transaction generator. There are about 2 or 3 components in it. My bar here is blocking my ability to see that. So in here in the main, you can see that this is configurable. So you can give it, point it at where you want to target these. And currently we, in the transaction generator, the transaction provider here, this is what determines how these will be sent out on the wire. And so currently we're using and supporting the P2P interface. And so anything that the transaction generator creates, it will send out on the P2P interface directed at the Node.EOS instances that you're using. So you kind of configure it to point at, if you've got multiple instances, maybe you want to fan those out. But that's how it's currently working, and we're looking to expand that to support, the HTTP API as well. And then in the transaction generator itself, there are several different types of generators that we've created. The basic one is just a blind creating of transfer transactions that it will send out and create a whole bunch of token transfers to do that basic measurement. And that was the first step. And we've since expanded that to allow you to provide some simplistic transaction descriptions in a JSON format that allow you to kind of expand that and see what, or to test different kinds of transactions. And so there are a couple in the code base right now to give you some examples. If you jump over into the performance tests, there are a RAM transaction, there's another data. So it's pretty simple. You can kind of see how it's done there. And there are some abilities here to, like, for instance, testing new accounts, new account creation. We wanted to get some performance metrics around that. And so you can see how that was specified here. I'm not going to go into a huge amount of detail here, but I'll leave it as an exercise for users who are interested to go and kind of dig in. And if you have any questions, let us know. So those are kind of walking back up through the transaction generator. The performance test basic, once again, uses that to create a load and then measures the information coming out the other end. And so to give you an idea what that looks like, I'll jump over. This is a larger report of the full test suite running, but inside the test suite itself, inside the report that the test suite builds, when it finds what the kind of the max sustainable load is, it will include the low-level test report in full for the specific run that it determined is the best. And so here you can see, I wanted to kind of walk through the types of information that are available in that report for you to see. So here you can see that you've got your start and end times of the test run. This is useful to kind of zero in on what logs may be associated with this run, and also to give you an idea of how long these runs are taking for planning reasons. You've got some information on the block size during your run, some statistics around that. This blocks guide is information about, out of the totality of the blocks that were generated during the test run, which ones were used for the analysis. So we do some work to kind of zero in on that steady state of block generation and transaction consumption, so that you're not getting kind of those outliers when things are spinning up and things are just getting going that will affect your performance numbers. Then you've got some details here on the TPS, so your transaction throughput, your min-max average, how many you actually got, what your configured transaction load that you were attempting to achieve. This also gives you some specifics on how many transaction generators were spun up to accomplish this, and how many transactions they were each given as far as what their load was supposed to do. And then coming down here, we also, for the transactions that were analyzed, looking at what was their CPU usage, what was their latency, and the latency here is measured from send time until block inclusion time. So you can see how that was working out. You've got your transaction net statistics. And we've also got information here about dropped blocks, production windows during the run, and forked blocks count. And these are have some additional work being done on them as well. In future releases, we intend to continue to build this out, so this is even more informational. And then to help, because this is a test suite and you may want to be able to reproduce runs like this and see maybe how your performance is improving or degrading as you do work and create features, we wanted to be able to log all the parameters that were used to do this log generation. And so we did a very detailed view of all of the different configuration parameters. Now, not all of these are specified, but we actually do the work to pull out Node.EOS defaults for all of the plugins and provide that in a full readout here, so that if something in Node.EOS were to change, you could actually see kind of what the defaults, how the defaults are changing and how that might be affecting things. But that's a look at the low level, kind of the performance test basic report. And then if we step up one layer more, we've got the performance test. And this is kind of the high level. This runs a suite of these tests. And so what do you get here? You get a full run of using the performance test basic to kind of search the TPS space. And so we do kind of an initial binary search through a large range of transaction per second load. and find out kind of in a little bit shorter performance runs what the max sustainable TPS is, and then follow that with a smaller window, kind of zeroing in on the sustainable TPS that your system can support, and do some longer runs to really zero in on what the kind of the max sustainable transaction throughput your system can support. And there are some additional parameters here that you can tweak, like how long you want the test to run, what is your max TPS to test. You can kind of shorten the window of how long this takes to run. And then there are 2 or 3 other test capabilities here. There was some question about adding threads to the different plugins in Node.js and seeing how that affects performance. So we actually provide some automated ability to run through the number of threads that you're allocating to each of these to kind of zero in on how they're affecting the performance and give you kind of an ideal, it's kind of a naive implementation, but at least it gives you an idea of how the number of threads are or are not affecting the performance. And once again, this is all kind of summarized in the README here. I'll leave you with that. And that's kind of what I wanted to get through today. So thank you.
Excellent. Thank you, Peter. Exciting stuff. Looking at the time, we probably will not have time for Q&A today. But if you please take note of any questions you have and send them my way at bhazard, as Stephen pointed out, with 2 Z's, P-H-A-Z-Z-A-R-D on Telegram. I'll make sure to funnel those through so I can get you answers. With that, Kevin, you've got a lot to cover and you've got 15 minutes. Daniel, real quick, as a housekeeping thing, are we good to run over by a few minutes?
Yes, you are. Yeah. Let me see here. My calendar. I might have to drop, but no harm. Actually, I can hang around a little longer too. All good.
All right. Thank you, Kevin.
Great. So I'm going to attempt to go quickly here and not in any great depth on any of the topics that I'm going to cover. So again, hit Brian or me up on Telegram and we can answer any questions you have. So the first thing I want to talk about is the auto peering capability for BP nodes that allows you to configure BP accounts along with their connection, their endpoint that you want to connect to. And then what I'm going to show you here, what I have on the screen, is just an example of the tests that actually we have for this, that the integration test we have for this, just to kind of show you how this is working. So here we see, I scroll up just a little bit here. So the producer is ESIO at this point, and then we're promoting the schedule to a new set of producers. I think it's A through U or something. Anyway, a whole new set of producers that's happening right here, promoting that proposed schedule. And then you'll see if I find the block that's being produced. Okay, right here. So I'm actually with ESIO, but if I go down a little bit, I should see a block that's not ESIO. Yeah, here we go. Producer, def producer E. So you see that the producer schedule has changed. So if I jump back up to that where that was changed. So now the net plugin reacts to a proposed schedule change like this, and it says, oh, my pending downstream neighbor for this particular producer, so this producer here, its downstream neighbors, or the next 2 producers in the schedule, are R and S. Def producer R, def producer S. So that's its pending neighbors. Well, it's been configured with those endpoints for those 2 producers. And so what it does is it attempts to connect to those. And that's what's happening right here, adding new connection for 4, adding new connection for 5. And so after that, there's handshakes, yada, yada, yada. It's after this point, wherever the actual message is, doesn't matter. It's then connected to those additional endpoints that are part of that schedule. And then later on, which I won't show you here for time, it would, if it had connected, now in this case, this is the first from going to ESIO to a set of producers, so there aren't really any previous connections. But when the schedule changes again, R and S, let's say R and S are no longer downstream, it'll actually disconnect from R and S and connect to the 2 nodes that are downstream. Now, if R is still downstream, but S isn't, it'll keep it, but lose the other. And so it massages the connection as the schedule is changing. And that's all according to the configured BP schedule there. So that's really kind of all I wanted to show for that. I'm going to pull this over here. I believe you should be able to see that. I think I'm sharing my whole screen. The next up is the Prometheus Exporter Plugin. And not really going to show much here, just a couple notes on it. The fact that it is IPv4 for the 4.0 release. Now, we do have plans to make that support IPv6 in the 5.0 release, but for now, we're focused on IPv4 for the 4.0 release. And it does now, as requested, allow a different port to listen on. Our initial implementation, we actually had it on the same HTTP port as everything else. Requested to actually move that on to a separate port. That is now possible. We just specified the Prometheus Exporter port along with the plugin. So to enable it, you simply enable the Prometheus plugin, like you do other plugins, and then add the Prometheus Exporter port for the given port that you want it to listen on, and then it will serve that endpoint out, which is V1 Prometheus metrics is that, and that information is in the release notes. All right, quickly moving along here. Log splitting, we talked about this a little bit last time, but just kind of talk about it a little bit more. Related to the splitting out of logs is there's actually a new option that has nothing to do with that per se, but I put it in the same category. We do allow you to specify a different state directory now for Nodius. So it's in the same vein of being able to put various persistent data and various locations on your file system. And so the state directory allows you to put the state somewhere else. And so that's useful if you want to run your state on, say, a high-end SSD drive, but you want your block log and maybe your ship log on maybe a slower, rusty hard drive. You can separate those out accordingly. And so in 4.0, we have the ability of specifying a blocks log stride and a state history stride. Here we go, state history stride. And those are so they're analogous. It's the same thing. One for block log, one for the state history logs. And so it's the same sort of capability. You specify a stride, which is the number of blocks that you want to have in each file. So a stride is a file. Here we have 10. Now, obviously, you wouldn't want to use 10. You probably want to use 10,000, 100,000, maybe a million. I don't know. Whatever number of blocks you want to put in each file. And then you can indicate, if you like, the number of retained blocks that you want to keep around, and those are within the retained directory. Now, this is relative to the blocks directory, or it can be an absolute path. So if you specify an absolute path, it won't be relative to blocks directory. It can be in a completely different location, completely different disk, if you will. And then there's the archive. Now, the difference between the retained and the archive is the retained are live. So Nodius has access to the retained and will serve those out, even though they may be in a different location. The archive are not available to Nodius. Once they move into the archive directory, Nodius will no longer know they exist, if you will. It kind of shuffles them off there and then forgets about them. And that's the same specifications for the state history, same behavior. Okay. Continuing on here. So the other thing that we have in 4.0 is lighter validation for relay nodes. What we mean by that is faster block propagation. So there's a number of things in 4.0 that makes the block propagation faster. One of the things is that we just optimized that plugin. There's a number of optimizations there in the ways that it handles blocks and the way that it sends those out. Those are somewhat micro optimizations, but hopefully they'll make a little bit of difference. The big one is that we actually propagate blocks now after a header validation. And not only that header validation is actually not even done on the main thread. So a block can come into a node now, it can validate that header all off the main thread, and then propagate that block to all its peers without ever disturbing the main thread that's over here working on, let's say, processing transactions. And so a block should be able to propagate now much quicker in a 4.0 environment, as it simply does header validation and propagates that along. So in terms, to give you an idea of what that means, let's say on mainnet, the max block CPU is 200 milliseconds currently. So that means that typically for a full block, it's going to take you about 200 milliseconds to validate that block. So before this change, every hop along the way is a 200 millisecond delay as you validate the block and then pass it on. Now that has been reduced to whatever it takes to do a header validation, which is, maybe 1 millisecond, as opposed to 200 milliseconds. So huge improvement in terms of time as it jumps. And of course, for each hop, before that is 200 milliseconds and then 200 milliseconds and then 200 milliseconds as a block made its way across nodes. Now, each of those are just going to be like, a handful of milliseconds as it does block header validation. So much, much faster block propagation. The other theme of the release, as Brian was talking about, is multi-threaded support. That's done not only in what Lynn was talking about in terms of providing parallelization during these read windows, but even if you don't even have that feature enabled, so even if you just go with read-only threads at 0 and only have a write window, there's still a number of multi-threaded improvements in 4.0. Two big ones are the block log and the fork database are both thread safe now, which means that we can take advantage of that. The net plugin can now serve out blocks, for example. So a net plugin that's serving blocks to its peers can do that completely off the main thread. So it can retrieve a block, package it up, and send it across the network without ever disturbing the main thread. And it can do that concurrently across multiple connections. So let's say you've got 10 peers all wanting different block ranges. It can be serving all those at the same time without disturbing anything else that's running. Included with that, we've also optimized the get block call. That's a call that has been very slow in the past. And one of our test cases, actually the one that we were using as testing, we saw a 4x improvement in the performance of get block. So rather hefty improvement in the terms of getting that. And even, so it's faster, period. Plus, more than half of its time has been moved off the main thread. So before, all that processing was on the main thread. So now it's 4 times faster, plus only about half of that time is actually on the main thread, or I think even less than that. Some fraction of that time is actually on the main thread. The rest of it has been moved completely off the main thread. It's now running in the HTTP thread pool. So giving your HTTP thread pool probably more threads in 4.0 is going to be useful because we're taking advantage of those threads for a lot greater things, a lot more things. Included with that are 2 new endpoints: get raw block and get block header. These are nice because they don't do the expensive things that get block does. That is converting it all into expanded JSON. It simply returns the block unexpanded and allows you to then do that processing on the client. And so those endpoints are now available in 4.0. Hopefully those will be very useful, particularly the get block header. We anticipate that being very useful for light validation work or work along the lines of the new instant finality stuff that's important. Ship locks have been made thread safe. That allows us now for the ship to serve out its data without interrupting the main thread. So now ship can serve all of its clients without interrupting the main thread. So now the ship is not, so there's only 2 threads there, the ship thread that's serving all its clients, and then the main thread that's writing to the ship logs. But the one thread that's serving all the clients doesn't interfere with the others. And so it's not multi-threaded in terms of a thread per connection, but it has a separate dedicated thread for serving all of its clients, which should should help the throughput there. Along with those sorts of changes, the Gelf logging, turns out that was pretty expensive, and it was all on the main thread. Now moved that off the main thread, and so the Gelf logging should not interfere with performance like it does in before 4.0. So it actually slows the node down quite a bit, which was a bit of a surprise to us. But anyway, so that's all been moved off into its own thread, so it doesn't interfere with the main thread processing. Along with that is we've made various optimizations to the HTTP plugin. So not only is it taking better advantages of the thread pool that you're giving it, but also just in terms of the processing that it's doing. So it's doing less string copies. It's doing faster JSON parsing. Now, and I'm hopeful, I don't know when we'll get it in, but sometime soon, we hope to move actually to a better JSON implementation. The JSON implementation we have is not great. It's back to 1.0 version of Node.js. It's the same JSON parser that's been there forever. It's not a great implementation. There's better ones out there that we want to move to. But even this one, we've made some improvements. One example that we saw was that, set code of ESIO system, as an example, the JSON parsing for that has been reduced from 3.5 milliseconds to 1.4. So pretty good improvement there on that particular one. Hopefully that's across the board for all JSON. And it's not just set code. It's like every JSON interaction that you're doing, every get trace, every get block, all that stuff is now slightly improved with the better JSON parsing. Okay. Additional things, as I've run out of time, subjective CPU improvements in 4.0. There's some tiny kind of improvements there. We now enforce the subjective CPU on transaction deadline. It's a pretty small little kind of corner case, but it's there. We also apply subjective billing now on the producer node during the production window. We used to not do that. We now do. So it gives a bit better bookkeeping on subjective billing on the producer node itself. So again, pretty kind of narrow corner case, but those have been taken care of in 4.0. There's better logging throughout, so not just Prometheus support, but just in terms of various logging improvements. One big one there is that the CPU usage now tells you why the CPU was exceeded, which I think will be useful for users. Gives them a better understanding of what limit did I hit when I ran out of CPU. Was it subjective? Was it consensus? Was it node configured? Those sorts of things. So it now tells you which of the various configuration options your particular transaction has exceeded, as opposed to before just saying, "Hey, you ran out of something. Good luck figuring out what it was." So now it's much more descriptive. And then lastly, there's been a lot of talk on this call about the resource monitor. So in 4.0, there is the new resource monitor space absolute setting. So you can set you can do that. You can set an absolute setting for the threshold as opposed to a percentage. And that's been, I think, again, talked about many times on this call. And so now you can set that as a gigabyte setting, whatever you want that to be. And that's going to be per all the various nodes or disks that's monitoring. And that will override the percentage setting. Okay. So I've run out of time, so I'm going to end there. Yeah, that's it.
Excellent. Thanks everyone for your demo and overview today. We are over time, so I'll hand it back to Daniel after one last thing, which is just, again, if you have any questions, please, by all means, reach out to me on Telegram @bhazzard. That's BHAZZARD. Be eager to get answers for you. Thanks. And with that, Daniel.
Thank you, Brian, and thank you to everyone for the demos. Looking forward to sharing that more broadly with the community. So yeah, we'll post up that video recording as soon as it's ready, and we'll see you again next week. I guess next week we're back to continue the special purpose node discussion. So we'll see you all next week to continue that discussion. Thanks, everybody.
Bye.